Good day. My name is Becky Peremoboere Bamiekumo, and I'll be presenting on AI-based rainfall anomaly impact assessment on vegetation stress in Oxfordshire, United Kingdom. This study focuses on how artificial intelligence can be used to analyze abnormal rainfall patterns, which is also known as rainfall anomaly, and their impacts on vegetation stress. Rainfall is a very important factor in plant growth, and a situation whereby rainfall is significantly above or below the normal level, it causes vegetation stress, which may lead to reduced productivity, reduction in plant growth, and even environmental degradation. So, this assessment matters because rainfall deficits create uneven vegetation stress across agricultural, peri-urban, and mixed landscapes. Also, remote sensing captures canopy greenness and moisture through the normalized difference vegetation index, which measures how green and healthy the vegetation is. The enhanced vegetation index, which give account, is also similar to the normalized difference vegetation index, but it gives account in an area where the vegetation is more dense. Then also remote sensing captures the normalized difference moisture index, which give account of the moisture content of the vegetation, how water affects the plants, how the water stress the plant, and also the soil adjusted vegetation index, which give accounts for the soils. Then also this assessment matters because AI combines rainfall, terrain, land cover, hydrogeological, and urban context variables into mapped classes. So the objective of this study is to predict the spatial vegetation stress driven by rainfall anomaly in Oxfordshire, to identify the dominant rainfall and vegetation index drivers using explainable artificial intelligence, and to produce practical maps for environmental monitoring and climate impact assessment. Here we have the predictor group and the variables used. In order to predict the rainfall anomaly, we use the annual, the spring, the summer, the autumn, and the winter rainfall. In order to predict the vegetation condition, we use the normalized difference vegetation index, the enhanced vegetation index, the normalized difference moisture index, and the soil adjusted vegetation index. In order to predict the terrain and land surface, we use the digital elevation model, the slope, the land use land cover, the bedrock, and the superficial geology. The hydro-urban proximity, how close water is to the infrastructure. We use the water course, the greenscape, buildings, and the roads to predict the hydro-urban proximity, how close the water is to infrastructures. To predict the derived stress, we use the rainfall deficit pressure, the rainfall anomaly impact index. So among the machine learning models tested, the logistic regression leads performs best at predicting the vegetation stress caused by the rainfall anomaly, and we have a test accuracy of 0.993, meaning this is almost a perfect prediction. Also, we have the F1 score, which combines the precision and the recall. It ranges from 0 to 1, and the value we have here is 0.993, which indicates almost a perfect classification. Also, we have the area under the score is ranges from 0 to 1, 0 to 1, that's 1 means the perfect classification, 0.5 to 0 means random guessing. So since the value we have here is 0.9999, it's close to 1. So it's almost a perfect classification here. So the class-wise performance and the model comparison, we have 5 classes. We have very low, low, moderate, high, and very high. So all five stress classes exceeded 0.988 F1 score. It is extremely high. Errors were mainly between the neighboring classes, not across distant stress condition categories. The target was balanced across the 5 classes, supporting 5 fair class comparison. The model is reliable for spatial screening and stress separation, but field validation remains important. So moving forward, these are the partial rainfall stress outputs. And here, higher vegetation stress appears mainly in the eastern and southeastern Oxfordshire. Here we have the rainfall deficit, we have the rainfall anomaly, the vegetation stress, and the area by the stress class. And higher vegetation stress appears mainly in the eastern and the southeastern Oxfordshire, while the lower stress is more frequent toward the western and the southwestern areas. The map interpretation here, you have the rule-based stress classes, the machine learning stress class, the machine learning prediction confidence, and the confusion matrix. So the machine learning stress class map closely. The machine learning class map closely follows the rule-based targets. Very high stress patches expand in the southeastern zone. The prediction confidence is generally high. The lower confidence occurs near fragmented class boundaries and sharp translations here. So here we have the vegetation stress class area summary. We have the 5 classes: the very low, the moderate, the high, and the very high. And we have the area in kilometers square and the mean stress. So as you can see here, each stress classes covers roughly 1/5 of the mapped area. The mean stress increases steadily from very low to very high classes. The mean rainfall anomaly impact also rises from 0.118 to 0.528 across the same class. The mean stress is very high because it has a value of 0.582. So the explainable artificial intelligence, the key predictors, we have the dominant drivers, and the dominant drivers are the rainfall anomaly impact index, the rainfall anomaly and rainfall deficit pressure, the normalized difference vegetation index, the normalized difference moisture index, the enhanced vegetation index, and the soil adjusted vegetation index. The autumn, summer, and winter rainfall as the secondary controls. The sharp output indicates the model it used both rainfall, pressure, and vegetation condition, as you can see here. So these are the key predictors and the dominant drivers. So the main interpretation here, the rainfall anomaly predictors and vegetation indices, they are strong indicators of spatial vegetation stress in this study. The elevated rainfall anomaly impact aligns with higher stress values and more frequent high or very high stress classes. The logistic regression offers a transparent and computational efficient model while retaining excellent accuracy. The important limitation here, the vegetation stress classes were derived from a composite index, not field observed stress measurements. High accuracy therefore confirms agreement with the design stress targets. Future validation should use field observations, crop yield records, soil moisture, or independent drought impact data. So in conclusion, an interpretable AI artificial intelligence workflow successfully mapped rainfall anomaly impacts on the vegetation stress in the Oxfordshire. Logistic regression achieved 0.993 test accuracy, 0.993 macro F1 score, which combines the precision and the recall, and a macro area under the curve value of 0.9999. Higher vegetation stress is mainly concentrated in eastern and southeastern Oxfordshire. The rainfall anomaly impact, rainfall anomaly, rainfall deficit pressure, and the vegetation indices, they are the leading drivers in this study. So thank you very much, and these are my references. Thank you.